have you ever thought about what really keeps a hospital running? And I'm not talking about the amazing doctors or the high-tech scanners you can see. I'm talking about something completely invisible, but just as critical for saving lives. It's the air itself. Seriously, let's dive into this unseen healer.
Okay, so let me ask you a pretty simple question. What's the main job of an HVAC system? You know, the heating, ventilation, and air conditioning in a building.
You'd probably say to keep us comfortable, right? Warm when it's cold, cool when it's hot. And you know what? For just about any other building on the planet, you'd be 100% right. But inside a hospital, comfort isn't the main goal. Not even close. It is a completely different world.
So here's our game plan. We're going to see how a hospital's air system is so much more than a thermostat. It's literally an instrument for healing. We'll look at how it creates an invisible shield, how it contains dangerous threats, and how it all comes together to act as the hospital's immune system.
First up, let's just completely redefine what this system is even for. We've got to shift the whole mission from just being about comfort to being about active patient care.
I mean, this says it all, doesn't it? In an average office building, it's all about making people feel comfortable. But in a hospital, the entire system is re-engineered around a single mission: patient treatment and safety. If you happen to feel comfortable, well, that's just a nice bonus.
Okay, so if it's not really about comfort, what is it about? Well, this is where it gets really fascinating. The system is engineered to be a medical tool. The actual air becomes part of the prescription.
So let's imagine patient A. They have a severe lung condition, and their body is producing this thick stuff that makes it incredibly difficult to breathe. For them, the HVAC system delivers a very specific prescription: warm, highly humidified air pumped right into their room. That moisture helps thin everything out, making it easier to breathe. The wrong air, say cool and dry, could actually make them sicker. Now get this, in the very next room is patient B, who has a traumatic brain injury. Their body can't regulate its own temperature, and a sudden fever could be catastrophic, causing even more damage to the brain. For this patient, the system does the complete opposite. It delivers a constant, steady supply of cool air to help keep their body temperature stable.
Just think about that for a second. We're asking one system to deliver two totally opposite, medically critical environments to rooms that might literally share a wall. That is an incredible engineering challenge.
But wait, because temperature and humidity, that's only half the story. The system also has to create invisible shields, and it does this using something you can't even see: air pressure.
It all comes down to something called an air pressure differential. It sounds complex, but it's really just the difference in air pressure between two areas. By controlling this with extreme precision, hospitals can literally tell the air where to go, creating invisible walls that protect everybody.
And this gets used in two critical ways. In a sterile space, like an operating room, you want what's called positive pressure. The system pumps more air in than it takes out. So air is always pushing out of the room, acting like a force field that keeps germs in the hallway from getting inside. Then you have the opposite, negative pressure. This is for an isolation room with a highly contagious patient. There, the system pulls more air out than it puts in, so air from the hallway is constantly being sucked into the room. That guarantees that none of the contaminated air can ever escape.
All of this, the temperature, the humidity, the pressure, it all leads to one of the most unbreakable rules in hospital design: containing the threat by controlling airflow.
This right here, this is the absolute red line. In an office building, air might circulate all over the place. In a hospital, that would be a disaster. Air from different critical zones can absolutely never, ever mix.
And the why is pretty obvious, right? You can't have air from an infectious disease ward drifting into the neonatal unit. You can't have air from a general waiting area somehow getting into a sterile operating room or a burn unit. This separation is total, often using completely separate ductwork and medical-grade filters that can trap the tiniest viruses.
So when you put this all together, you start to see that this system is really acting like the hospital's own personal immune system. It has two incredibly powerful functions.
It really works on two pillars. First, it's a therapeutic tool. It's actively part of the treatment, delivering those custom air recipes to patients to help them recover. And second, it's a defensive shield, protecting everyone by controlling air pressure and filtering out anything dangerous to stop infections before they can spread.
And that brings us right back to where we started. The reason a hospital room often feels comfortable has nothing to do with comfort being the goal. It's simply the positive side effect of an unbelievably complex system whose real job is treatment and safety.
It makes you wonder, doesn't it?
What other complex, invisible systems are working all around us, silently keeping us safe and healthy every single day? Something to think about. Thanks for joining me.